welcome to this episode of Tips and Techniques video series from Spanner Product Development. I'm Mark Biasotti, and over the next 30 minutes, I'll introduce you to some of my favorite tips and techniques to help you be more productive and create better quality data when using SolidWorks. So whether you're a seasoned SolidWorks user or a beginner, we think you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over 100 clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of SolidWorks Tips and Techniques series.
Welcome to this episode, SolidWorks Making Bulletproof Models. And I'm going to start this episode talking about how you plan out your strategy. So the diagram that I have in front of you, this flow diagram, is what we use with a lot of our clients to map out how we're going to execute in SolidWorks. It's extremely important when you have a team of people. It's important just for yourself, but it's especially important if there's multiple team members involved, and those multiple team members are responsible DRIs for certain parts of the design. Because SolidWorks is highly associative and parametric, you really need to be able to communicate with each other with your models and know who's working on what and how you will start out your design and then work down into a final assembly. This diagram has a lot to do with how we do master models in consumer products, and it illustrates that you can see up towards the top we have original master drive sketch. That's used in some situations where it's a very complex mechanism and there's a drive sketch that wants to drive multiple parts, if not multiple master models. And then below that in the yellow, this is where we have a number of masters that are driving different sub-assemblies of the overall assembly. Well, enough of this. I'll get more into this in a later episode when I talk more about master modeling, and I'll expand on it more. So we have some other topics to get to, and I'll go to SolidWorks to show you those. One of the essentials of building robust models is when you build features in SolidWorks and you're building new features on top of existing features, you want to make sure that you're not building on features that are going to change. Well, it's kind of an oxymoron because a lot of features will change in SolidWorks. But what I mean is, if possible, when building new features, build them on features that are by default not going to change. And so the first example of that are your front, top, and right planes. These are default planes that will never change. Your origin will never change. If you make X, Y, and Z axes going through these planes, they won't change. And by building new features and referencing and dimensioning to these features, you're ensuring yourself that you're going to have a model where when you do make changes, you'll make them and the model will update correctly. So as an example, let's say that we need to build a flash feature in this part of the camera at the existing point right now that we're in the feature manager. So my temptation, maybe without thinking too much, would be to select this face and start a sketch using this edge. Well, right now you can see that there's something a little bit odd about that edge. It's not complete. There's a break in it, what I call a dirty edge. It's probably the result of a split body. So rather than do that, let's find out what we can build on that's more robust. So the first thing I'm going to do is turn on my planes, and let's filter out everything but the default planes. So again, we're going to use our feature manager filter to take these planes and hide them. So now we can see we just have our default planes, and sure enough, the front plane is right in the middle of that split. So I'm going to use that plane to start my feature. So I'm going to click that, start sketch, normal to, and then you can see that instead of using this edge, let's go back to one of the more base features of this. Now, to find that can sometimes be a little hard to do. We can use breadcrumbs. So we can click on this when we're not in Sketch to look for where this cut existed. And it's split line 7 down here. And if we click on that, then we can also look at our dynamic reference to where that is pointing. So we're going to go up and we're going to see that it's going to some other split lines. If we do a little bit more interrogation of some of the first features and look at their sketches, we see that here's one of the base sketches. And this coincidentally is one that we really probably want to reference because it's very early in the part. It has a very base sketch. So we're going to show that. So let's make sure that's shown, and it is. And now we go back to our normal view of our sketch, and instead of that edge of the model, we're going to use the actual edge of the sketch. So we're going to convert that into our current sketch. And let me just do that. Well, we got to be in our sketch actually. So we're going to start our sketch on the front view. Click on this edge to convert it, which is one of our base sketch features. And then we'll draw the profile for our flash. So I'm going to start here. Bring another one up here. Do a 3-point arc from here to here because it has a crown on top of the flash. Make sure those are horizontal. And then draw our converted edge in to make a closed profile. And then and additionally, we want to dimension this in a logical and robust way. So the flash wants to be something like 30 millimeters wide. And we want to reference it off one of the default planes. Here's the right plane. And if you're not sure about that, you can see the pop-up there. If you're still not sure, you can always use your feature manager to start your dimension by going to right and then clicking here and getting your dimension. So let's get into the dimension actually and go from right to here to here. Now, I think what we're probably doing is grabbing a point here. Yeah, that over-constrained it. So you can see some of the good practices I've used. I've dimensioned off of known planes. I've used an early feature sketch to derive my new sketch. And for instance, the height of this, I'm going to either dimension it from this line, holding my shift key down and making this 16, or I could do it from my my top plane, which is another robust reference to dimension from. But the design intent here really doesn't make sense because probably is better referenced off of this bottom. So let's go ahead and extrude that. And again, we could pick a point off the front here. That would not be a good idea because if that fillet ever changes, then we lose that reference off of this feature. And this fillet comes before this feature that we're making. So what would make more sense is to do a end condition that is offset from this front face, because that's a pretty reliable datum. And we'll do something like 2 millimeter offset. And we want this to be a separate body because we're going to use it later. So let's unmerge it. And then I'm a big fan of using replace face because of how robust it is. Usually I copy a face, which is robust in itself. If you don't offset it, just make it 0. And then while that's selected, I go right to replace face, and I replace that reference surface with the bottom, and now I have that. So there's a couple examples of how you want to use your reference visualization to find the earliest feature in your tree and use that instead of the temptation of maybe building off the edge of a radius or another feature that is going to change. I believe another essential to building robust models is to be mindful that there are some features that you really shouldn't reference to build children features on. And there's no better example of that than fillets themselves. So what I'm talking about is using edges like these to actually dimension new features too. Fillets are things that tend to change towards the end of the design. There's aesthetic decisions that will make them change or be eliminated. So it's probably a good practice to try to build your models and then let all the fillets live at the end of the feature tree. That way you're building all the essential features and not referencing the fillet features. Let's see what happens to this model if we first just filter the fillets and just delete them. So we get quite a few features that blow up. Not too bad, but nothing we would want to have happen to us. So let's do this. Let's roll back, and then let's try to take all the fillets and move them to the end. So I'm just going to use my little folder trick to take and move these down. Add folder, move it down. Okay, that one's not going to move for some reason, which is not good. So let's take these and make a folder and move these down. Let's see if we can move this one now. Yeah. So what I've been able to do, let's see if we can move this one too. No, that one's not going to move. That's because it's created very early in the part, and there's probably lots of other geometry that's based on it. So we know that's just more like a nominal fillet, so we can delete that. And we see those features fail. Also, these all fail. So what I was going to try to do is salvage this model by moving all the fillets to the end. If we just take away their folders, you can see that happening. So this is the kind of structure that I'm talking about. That is a better structure because then features like this can change and aren't dependent on the fillets themselves. A good example or a bad example of that is this fillet. So you can see when I delete this, we get lots of bad stuff happening. So I've taken this model and put it into a better form. So if we go to Good Toolbox, you can see we now have a model with all the features at the end. And this model is more robust because when the base features and features above the fillets change, it's likely that the fillets will update on top of them. It's just another benefit of having all the fillets at the end is then you can easily reorder fillets to get a better solution and avoid edges like this, where if you were to fillet this before this fillet, you would probably get a better result. So just having them kind of all together in one area is better to be able to get a better solution between fillets. So that's another good reason for putting it towards the end of the tree. On the subject of robust modeling, one of the features that I often employ in my models is move face. And the reason I do it and use it as a feature is because it's a robust feature, it's safe. And what I mean by that is that a move face is simply that. It's moving a face. It's not changing the face ID as if you were to cut or extrude onto an existing face and you reference that feature afterwards. Once you cut a face, its ID changes. That's not the case with move face. It's rather like draft also. If you were to draft something and reference the edge of the draft, if the draft changes or goes away, it's not going to affect the child reference. So as I like to do in models, this is a generic box, 2 halves with a parting line as step. I like to use move face as a feature for tolerance. And so on this model, if we were just to turn off the transparency here and put through a section, right now I have a step going on here, and it's line to line, and I need to do some changes to that to make it more realistic for manufacturing. So the first thing I'm going to do is use my select other here to grab the bottom face of the upper housing here, and I need to create what's called an appearance gap. So if we create like a 0.75 appearance gap, and we move up that face, now I can see that I'm grabbing the lower housing face, so I think what I'll do is I'll move that down. So move face always moves out by default, and then if you flip direction, it moves in. And I think that's what's happening here, yeah. So I have my appearance gap that I need so that it kind of hides the mismatch in tooling between the upper and lower. And then the next thing I'm going to do is grab, I think I'll grab this upper inner face to put some tolerance between the lip. So again, I'm going to use select other, and I think the best way to do this probably is just to hide this part and then use this and then select tangency, which even though it's sectioned, it's actually going to grab the whole interwall, and then use my move face again. Remember, by default it moves the face out here I want to move it in by 0.12 and flip my direction. And then I can go ahead and show my lower housing again. And now you can see that what I've done here is to create some tolerances. And you can even name them in your feature manager, and I often do. So this one is the appearance gap. And this one is lip tolerance. So I've also noticed that, this wall gets rather thick up here, and I think I want to move this away and kind of match this thickness below it with this lip. So let's just measure it. And nice thing about measuring in sections, it actually grabs the section. And so I have 0.279 that I want to move that wall. So I think what I'll do is let's just show this upper housing by isolating it. And let's just take all of this geometry here by tangent selection and do a move face on it in, I think it was 0.279. And then exit isolate, turn on my shell again, I'm sorry, my section. And actually I grabbed the wrong wall. So let's go back to this feature, but first let's hide this part. And I see that I'm going to have to try to do it before these ribs go in. So let's find those ribs. So we see that there's this thin extrude thin one. We're going to just try to move this up before it. And now we have to reassign that face by clearing this selection and then doing a tangent selection here. And it's kept my same value. And also it's rebuilt on top of that move face. So this goes to prove what I was saying, is that even though these ribs actually reference that edge, I moved that edge, but it still kept the reference. So that's what I'm meaning by it being a very robust feature to use in SolidWorks. And so there you can see the change that I've made and how I'm using move face. Another important aspect of building robust models in SolidWorks is planning out your work before you even start to build models. And one aspect of that is to look for symmetry and build only half the model. Why build the full model when you can build half of it and then in a single step mirror it to complete its full design? I see this mistake all the time, where people will build models, and rather complex models like the ones shown here. But if you do a little planning ahead of time, you can really save yourself a lot of work, a lot of modeling work, and make for a more robust model if you look for symmetry in your design, either something you're reproducing or something that you're originally creating. There oftentimes is symmetry that will help you to be more efficient and do less modeling. And then the less modeling you do, the less features, and then the less features to actually go wrong. So that's what I mean by it being a robust model, when you can model 1/2, 1/4, 1/6, 1/8. Look for the symmetry. For example, this ski mask, a large amount of spline and surface work to create it. And I wasn't going to even try to attempt that, doing both sides and have them both match. But it is symmetrical because our face is symmetrical. So after all this work is done, it's simply a matter of just mirroring it. And any changes you make on the left side of the mask reflect to the right side. Another example would be this Downy bottle. You might look at it and say, not symmetrical. And you're right, from a front view it's not symmetrical, but from a side view it certainly is symmetrical. So you have a plane right here, and if I turn off my perspective, you can see that there's a plane that reflects the front to the back. So in essence, this bottle is just made one half and then reflected over. Now, there are some aspects of this model and of all consumer products that aren't symmetrical, and there's combined parts and bodies. For instance, the cap is not symmetrical, but in essence it is. It's just symmetrical in a different way, where it's patterned by 3. So this cap was made just 1/3 and then circular pattern to complete the entire cap. We move on to a few more examples. The game controller, of course, it was modeled just half, and then any asymmetrical features were added after that mirror. So controls basically are not symmetrical, but the hard work of the body is. And so even the triggers and the main form is pretty symmetrical. So it's really modeled just half. I mean, we could probably find that if I go to mirror and look at where our mirrors are. And so if we edit this feature, you can see, yes, right there, I'm mirroring half of it at this stage, and the rest of it is just added after that. This example is a great example of what I'm talking about, because it's a rather complex bottle, especially the intersection here between these lobes. And really, after some lengthy analysis of how to design this efficiently and robustly, it's really done in 1/6. So if you look at the top view, we have, let me go back, you can see this completed model. And if I roll back and look at just this area, it's 1/6 of the model. So it combines just building that one section and then taking that section and mirroring it. Let the feature manager catch up here. So I'm mirroring it there. So that becomes 1/3, and then I pattern it in 3, and then combine it, and then shell it. So the takeaway there is that I can easily work down before any of the mirrors or the patterns to make any changes I want, and that will reflect throughout the whole model. It's really a great way to build, because then changes come much more easily by just modifying the 1/6 of the model. And so I think that's a really good example that it's not just modeling 1/2, it can be 1/4, 1/6, 1/8. Wherever you can find the lowest common denominator to build the model, and then save your mirrors and your patterns to the end of the feature tree. Another technique you can use to build robust models in SolidWorks is to use what's called a reference sketch to drive your various features in the model. And in this version of the camera, I have a reference sketch here, sometimes called a skeleton sketch. And it basically contains all of the important parameters of your design. And then as you have this sketch as the first feature in the model, many of the successive features are driven from this layout sketch. So for instance, if we wanted to actually change something, so we could actually just double click the sketch and then double click on a dimension, And that's not working because I have perspective on. That's a problem with perspective in the scene graph. Sometimes it's hard to grab dimensions. And let's make that 30 versus 20. And so as we rebuild the model, you'll see this space right here change. And this is like a 200 feature model. Let's see, undervaluate. Always have a hard time finding this. Performance is a 203 feature model. And let's just undo. Let me turn on wire or edge view, and you can see this. So if we go back to our sketch and make it 25 again, you'll see this part of the model change. Now that's pretty amazing for a model like this because there's a lot of surfacing in this model, and I wouldn't recommend doing reference sketches to drive surface models. There's just too much going on with surfacing, especially being driven by curves. Curves can't be easily fully dimensioned and driven parametrically. So oftentimes if you try to do it with a reference sketch and you have a lot of surfaces in here, like these and a lot on the back here, that they just won't update parametrically in a correct way. So I wouldn't really recommend that. But this does nicely illustrate what you can do if you carefully build your features off that reference sketch. Now, of course, what's happening here is if we go back to the very first base feature and edit its sketch, it's not actually using the reference sketch. It's using it to project entities from that reference sketch. So you don't touch the reference sketch after you created it. You're just referencing it by doing convert entities off of various elements of it. So just to make that clear. And then from that point on, you're doing that for a number of different references in the reference sketch. So that is how you use reference sketch. Now, when doing models that contain lots of features like consumer product models usually do, and especially in the master model, you're left with a large tree of features. And it could be hard to navigate this when you go back to it a week or a month later and want to affect a certain part of that model. One of the things that is very effective in overcoming that problem is to folderize your tree. And so I'm going to walk you through the process of doing that with this camera model. And I might speed up the video at certain areas, and just so that it won't take as long for you to watch me do this. It is a 208 feature model. But you'll get the idea of what I'm doing here, and then I'll slow it down at the end and then conclude. So the first thing you want to do is to name your bodies in the multi-body model. This is important so that you can find those features quickly or isolate the body so then you can work on it. But it's also important when you export this, either IGES or STEP, those body names come through into the import of whatever system it's going into. So that's important information for people who are on the receiving end of this work. So you want to name your bodies, and then starting at the top of the tree, let's just roll back to something like right here. We see that we have some reference features here. So it's logical to put those in their own folder. And so I'm going to put them in a folder and call them reference. And then After that, usually I start to work on the main body or the main form. And let's just turn off perspective here for a second. And I usually name, that's a very important feature, and I usually call it base feature because that has a huge effect on everything that follows. So let's just roll down until we see that we've pretty much created our main form, and something right about there. Okay, so I'm going to take that, and it's a natural to folderize that. So I'm going to call that main form features. And then continuing down my tree, looks like I'm working on the rear screen area. And then the next thing I'll do is probably be moving into the interface area. Let me show my tangent edges. Yeah, that'll help. So yeah, so there you have another important group of features, and I'll call that the rear screen features. And then as we keep rolling down our tree, we see that we're starting to build the interface area for the rear controls. So I'll roll down and get those features in there. And I'm starting to just detail those buttons like so. You know, I noticed, and this is part of the process too, that this screen inset, it really should be up into the rear screen features. So what I'm going to do right while I'm here, I'm just going to take that and I'm going to drag it into this folder. And so when I'm moving it up in the tree, and it just makes more sense for it to be up there. So if you can see, I roll back. Now I've included that with it. And there's probably a fillet there too that I'll put into that area. Okay. Continue to roll down. Buttons, and I think that'll do it for that. So I call that group features. Rear controls. Did we do that? Into that area, extrude, looks like I've got the shutter button right there. And you can see that there's probably more details like a fillet and whatnot that is to be included with that. But for right now, I'll just folderize these three features, and then I can add to that folder. That's what's great about folders, is that once they're folderized, then you can drop other features in them that you find further down the tree, like what I showed earlier. So, and somewhere in here, it looks like in my rear controls, I was also creating my my lens details here. So that's another good example, I guess, of how I could take these features and roll them past where I was doing the interface on the back. So here you can see I've started some interface, but then I do my revolve for my lens. So what I'll do there is take that and put that into a single folder. We'll call that lens features. And then we'll see what we can do here. We're going to take that, drag it up here right underneath the rear screen controls. Okay, so now we've better organized those features away from these rear controls. Also, I've got a pocket here for my flash, and a pocket and an extrude my filters, those two. So we take those two and Folderize them and call that my flash features. And we want to take those and put them underneath this one. But we can't do it. So there's probably something here that's preventing me from doing that. So what I'll do is probably see if I can put those underneath this one. There we go. And it's still embedded in the folder, so that's not something I really want to do. But what I'll try to do is just right under this one. Okay, so I have flash features there. I have rear controls. So now we're going to look for. So you can see, remember my shutter button? So I put a kind of a crown on the top of it and replaced its face. So I can take those and put them into my shutter button. Or at least I'll try. It's probably because I have a couple planes I need there. So I'm just going to drag those in and include those in my shutter button features. And yeah, there's a fillet there too. So let's keep moving on. Looks like we have our movie button here. So we have schematic extruded, fillet, jump part of these. So we're going to roll right here and these are moving features. And then we move on. So it looks like these sensor holes, I'd like to really know where those came from. Yeah, and they were included in the top controls. So we're going to take those and we're going to roll those or move those down below here. If I can do that. No, I'm not going to be able to do that. So what I'll do is I'll play a little trick here. I'm just going to make a dummy feature. So we're going to take and create a sketch on the right plane as a dummy feature, just so that we can separate below that folder. And the reason I did that is so that now I can just drag this below this and then delete my dummy feature. So it's kind of a quasi workaround for moving things in the tree. So there we have that extrude and we have the chamfer. So with those two, I'll make those in a folder called Sensors. And then not sure what's happening here. I think this might just be some extraneous features. No, looks like we have a surface. Oh, I see. It's we're building a lens with a Fresnel in the back of it. So it is basically not sure what this feature is. Let's find out. It's another move body for the screws. So let's move that up to our screw folder. And then take our last two features and add them to the folder and call Flash Lens. So there you have it. I've folderized my model. It's a lot better to look at, and when you first open up this model, and I can go to any of my particular areas of the model, like my shutter button, and then immediately work on that and then roll forward. So I hope that shows you how valuable it is to take such a complex model and make it more easily understood through folderizing.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to excel using SolidWorks day to day. You'll see below some links to example models used in today's video. Feel free to download them and explore these techniques at your own leisure. Also, we'd love to hear from you. Please email me at the address you see here. If you need help on your design project or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.